Okay, so now for the trick to do this the easy way. Let's see if I did this right. Okay, so we talked about these two forces of tension were the same in the last video. Okay, so what I'm doing, see, look, I'm moving this guy here, I'm moving this guy here, and we're going to do something that'll seem a little weird at first, but just go with it. It's just a trick, because remember, we're just analyzing this like a system now. So I'm going to take this one. I've kind of removed him from the string, and I'm turning this on its side. Oh my god. Gravity is acting to the side now, the force of gravity. That's craziness. But look, I'm going to cover up these forces of tension. I'm going to kind of put this together. The forces of tension should go away. And actually, let me crop this because that's not overlapping the way I wanted it to. So I'm cropping that. Let me crop this force of tension off of here. Because the forces of tension, they're just the same thing, and they're canceling each other out when we look at what's happening to the system. Because remember, the whole system is accelerating towards the floor. So now, I'll just put these two on top of each other. And hey, look at that. What force is moving the system? Oh, it's the weight of 2. So let's go in and just do this like a Newton's pull problem. Remember, we got to write Newton's second law. That is, acceleration is directly proportional to net force and inversely proportional to mass. So let's find the acceleration of the system, I should say. And if you find the acceleration, you'll see it as the magnitude of acceleration. Find the magnitude of acceleration for 1. Find the magnitude of acceleration for 2. They have the same acceleration, the same amount. Just one's going off the table, one's falling down. But the whole system itself is just, sliding off the table, falling to the floor. So anyway, we're going to find acceleration. Hey, look, Newton's second law gives us an equation for acceleration. Now, let's see. In this thing, let's say it's accelerating that way. So acceleration is just your weight 2. That's your net force. That's the force causing the acceleration. It's your weight of 2. So mass 2 times acceleration due to gravity. Gravitational field. I kind of hit the equals. Anyway, and then, well, that's going to be over mass. But guess what? It's the mass of the system. So it'd be mass 1 plus mass 2. Awesome. Okay, so that's how you find acceleration of, and this is it. Oh, do not start simplifying this, guys, by the way. Just leave it messy. Because here's the deal. That is absolutely correct. That is easy to put into a spreadsheet if you're so inclined. Once you start messing with the algebra, you just give yourself more chances for mistakes. Just leave it. I like it this way. This is good. Okay, so now let's find force of tension for the system. Know that these are magnitude of the force of tension. Know these two forces of tension are the same. So anyway, since these two forces of tension are the same, we can just analyze one object and see what the answer would be. So now we're going to zoom in on one object. So we're just looking at Newton's second law. So I'm going to take this over here. And we know that this has an acceleration. The acceleration's right here. We'll deal with that in a minute. I'm just going to first solve it like acceleration. So you know that the net force acting on M2 only in this case, is equal to mass, and hopefully you should see, since you're just dealing with 1, the mass of 2 times the acceleration of the system. I should write this right here, system, up here, because that's acceleration. See, because it's got both masses. So the acceleration of the system. Okay, so therefore, let's look at your big force. Well, your big force is one going with acceleration, so that's the weight. Okay, minus the other one going the other way, which is force of tension. And that's going to equal the mass of 2 and the acceleration of the system. You can plug this in if you want. I'm not, because I want to make this a little bit, I don't want it to be too long. All right, so let's solve for force of tension. Here's the quick way. Add force of tension to both sides. So hopefully you see this goes away. Okay, and then subtract, oh shoot, I'm writing in red. Oh well, subtract M2, this is just your, another way to write net force, Newton's second law. Right there, so these go away, so that's your force of tension. See? All that equals, let me rewrite force of tension over here. All that equals force of tension. If you want to get really fancy with this, you could go M2G minus M2, oh goodness, okay, M2G over M1 plus m2, and all of that equals force of tension. So either way, as long as you draw arrows and show me that you knew that. So that's how you solve for force of tension. Tomorrow, it's not going to be this easy. There's going to be other stuff. Think about all the ways I could modify this and make it challenging. But just remember, this is a tool. You can't just like use this exact same thing. You got to prove every step. I have not shown any extra steps. Be prepared to do that.